Hi guys, welcome to another one of RT Dowlett lectures, and today I'll be focusing on questions. So I have had a previous video that was on Young's modulus, which is a module 3 unit 1 Cape Physics topic. Today I'm pulling out a couple of examples that are a little bit tricky. But it's just as a guide in case you may or may not get a question like this in your exam. So you have a rod and it has attached to it a copper wire and a steel wire which is suspending it from the ceiling. And you are told to find the point on the rod where a load must be hung so that the rod remains horizontal. So if the length of the rod given is 20 cm, which is 0.2 meters, you were told that the two copper wires of steel has a diameter of 1 millimeter and copper has a diameter of 2 millimeters, and you were told the respective Young's modulus of each material. So we're assuming that when the rod is hung, right, the weight is hung from the rod, that it becomes balanced. Now, when you talk about the rod remaining horizontal, then you're talking about the extensions on both wires being the same. So if you have a tensional force being applied, then you are going to say that, if you go back to the diagram, T1 and T2, you're going to get expressions for them, and you're going to use the principle of moments. All right, so when we talk about the rod to be horizontal, then you want the extensions from both wires to be the same. But because they are each made of different materials, then you would need to get expressions for that. All right, so the load must balance the moments due to each tension. And whenever you approach a question, you must have some rationale behind it. So when you talk about rod being horizontal, let the question help you, let the question guide you. So if the rod is horizontal and it's suspended by two wires vertically, then the extensions of those wires has to be the same. And in other words, the clockwise and the anti-clockwise moments provided by each tension must balance. So what I did is I found expressions for T1 and T2. So we're going to use the expression Young's modulus is stress over strain, which is FL over AE, right? And E and A are different, but the length, the original length of the wires are the same. That's what they said, and the extension has to be the same, right? So now we are saying that I had let wherever I put the weight be x from one end, and the other distance will be 0.2 minus x. So if we go back to this diagram here, T1 provides an anti-clockwise moment, whereas T2 provides a clockwise moment. So substituting T2x is T1 by 0.2 minus x, I've gotten a really large expression, and then I have substituted my values, or my expression rather, for T2 and T1. And based on that, I can make x the subject of the formula. Now I have variables for the area as well as the Young's modulus, because remember the E and the L would cancel, right? That's why we had made the initial assumption that for the rod to be horizontal, the extensions experienced by each of the lengths, whether it was steel or copper, would have been the same. All right, remember, once we're talking about a wire, to get the cross-sectional area, you're typically given the diameter in past paper questions. So what you do is that you use the expression A is pi d squared over 4.